It happens at night. Driving down the road, you're briefly blinded by the headlamps of an oncoming car. Or maybe you're on the highway when the vehicle coming from behind lights up the interior of your vehicle, causing a momentary distraction. Two potentially dangerous scenarios, and both probably preventable. In either case, the cause could be an unaware motorist driving with the high beams on. But oftentimes, the vehicle responsible simply needs a headlamp alignment. Hello and welcome to MasterTech. This month we're going to look at various procedures available for headlamp aiming, as well as some of the factors that can lead to misaligned headlamps. For instance, headlamps can become only temporarily misaligned due to trailering and variations in vehicle cargo loads, because the weight added to the vehicle can cause the headlamps to aim higher. Unequal changes in ride height, which may occur naturally over time, can lead to permanent headlamp misalignment. And damage resulting from an accident can have the same effect. Finally, if the headlamp itself is replaced, the new headlamp may need to be aligned. Today we're going to look at the various headlamp components and aiming components available on some Chrysler vehicles. After that, we'll go over different aiming techniques available to technicians, followed by the latest in headlamp control technology. Let's begin by looking at the components that make up headlamps. As automobiles evolve, so does their technology. Chrysler is always thinking of ways of producing easier-to-service, more reliable vehicles. The sealed beam headlamp, though still used in a few Chrysler vehicles, is being replaced with a headlamp that uses a replaceable halogen bulb, making service easier. Service isn't the only issue here, though. Since only the bulb is replaced, a wider latitude in vehicle design is possible. For example, headlamp styling can be more aerodynamic. And on some vehicles, the headlamp is incorporated with the park and turn signal lamps, something that isn't possible with the sealed beam unit. In the area of reliability, the halogen bulb itself has a longer life than the sealed beam headlamp and is versatile because the same bulb can be applied to different vehicles. In many cases, replacement is easier too, because the bulb can be accessed without removing the headlamp assembly. Let's look at bulb replacement on the Viper Coupe. With the hood raised, remove the access panel from the inner wheel well behind the headlamp. Then remove the headlamp rear cover. Next, disconnect the wire connector from the bulb socket. And remove the socket and bulb from the back of the headlamp. When handling the new bulb, either wear gloves or hold it by the connector. If oil from your hands or any other contaminants come in contact with the glass of the bulb, it could result in severely shortened bulb life. The Viper isn't the only Chrysler vehicle with easy bulb replacement. You'll find the headlamp bulbs on the Neon, minivans, Dakota, Grand Cherokee, Summit, Sebring, Avenger, Stealth, and Talon are easy to access as well. Vehicles that require removal of the headlamp assembly in order to access the bulb include the Cirrus, Stratus, and Breeze, Sebring convertible, LH vehicles, Ram van and wagon, and the Ram truck. Let's take a look at headlamp removal on this LHS. But first, remember that before you attempt to remove a headlamp, you should be familiar with the vehicle that you're working on. Turning the wrong screw could cause unnecessary headlamp misalignment. First, remove the radiator closure panel sight shield. Then remove the screws and separate the headlamp module halves. Disconnect the connector from the back of the headlamp bulb. And remove the retaining ring and bulb from the headlamp. On the Cherokee and Wrangler, sealed beam headlamps are replaced as a complete assembly. On the Wrangler, for instance, first remove the bezel retaining screws and the bezel. Then remove the screws holding the headlamp retaining ring. Disconnect the connector from the back of the headlamp and remove the headlamp. Of course, when we install the headlamp, we'll need to check for proper alignment. We'll do that a little later, after we discuss headlamp aiming components. But first, let's try a review question. Which of the following could lead to temporary headlamp misalignment? A. Headlamp replacement. B. Trailering. Or C. Vehicle damage. The answer is B. Trailering could lead to temporary headlamp misalignment because adding weight to the vehicle could cause headlamps to aim higher. When designing today's vehicles, Chrysler engineers always consider serviceability. This is evident when looking at some of the newest designs in headlamp aiming components. For example, many Chrysler vehicles are equipped with a bubble level used as a reference for vertical headlamp aiming. A bubble level like this one can be found on the Cirrus, Stratus, and Breeze, Sebring convertible, LH vehicles, minivans, Sebring and Avenger, Stealth, Talon, and Viper. If headlamp aiming is necessary, the bubble level method should be attempted first and then verified using the alignment screen. In addition to headlamp aiming, the bubble level can also be used to compensate for temporary ride height changes due to trailering or the increased weight of cargo. In addition to the bubble level, LH vehicles are equipped with a gauge for horizontal aiming. Cirrus, Stratus, Breeze, and Sebring convertibles use a gauge wheel, and the Sebring, Avenger, Stealth, and Talon use a horizontal adjusting gear. The minivan is equipped with a magnifying window. The horizontal 0 point must be visible through the window. Normally, horizontal alignment should only be necessary if the vehicle was tampered with or damaged. The bubble level and the horizontal gauge are both calibrated at the factory. However, if the vehicle was tampered with or damaged in any way, it may be possible to calibrate them. Keep in mind, though, that a screen alignment must be performed first. The bubble level on the Cirrus, Stratus, Breeze, and Sebring convertible cannot be calibrated because damage to the headlamp will result. All headlamps are equipped with a vertical adjustment screw and a horizontal adjustment screw. In a minute, we'll look at some of the headlamp aiming procedures, but first, how about another review question? True or false? The bubble level method for headlamp aiming should only be used to compensate for vehicle ride height changes. This statement is false. If headlamp aiming is necessary, the bubble level method should be attempted first and then verified using the alignment screen. Now we're ready to aim the headlamps using the bubble level. But before we begin, there are a few steps that must be taken to prepare the vehicle. First, make sure the vehicle is parked on a level surface. Then turn on the headlamps and verify that the headlamp dimmer high beam switch operates correctly. Next, inspect the vehicle for damage or defective components that could interfere with or affect headlamp alignment. And clean the headlamp lenses. Check all tires for proper inflation. And make sure the luggage area is loaded as it is normally used. Also, when aiming headlamps, the fuel tank should always be full. For every estimated missing gallon of fuel, add 6.5 pounds of weight to the vehicle in the area over the fuel tank. And if you're aiming the headlamps on a Sebring, Avenger, Stealth, or Talon, you should compensate for the weight of the driver. Either have an assistant sit in the vehicle or add 150 pounds of weight in the driver's position. Okay, now we're ready to aim the headlamps. For vertical adjustment, check the bubble in the bubble level vial. We'll want to begin with the bubble centered in the vial. If the bubble is not centered, adjust the headlamp by rotating the vertical adjustment screw until the bubble is centered in the vial. For horizontal adjustment, look at the gauge indicator. If necessary, rotate the horizontal adjustment screw until the arrow is centered. When you're finished, you'll need to verify the alignment. We'll do this with an alignment screen. The vehicle should be parked on a level surface 25 feet away from a flat wall. It's important to make sure the vehicle headlamps are an equal distance away from the wall. After determining where the center line of the vehicle meets the wall, tape a vertical line on the wall from the floor up 5 feet. To verify accuracy of the line placement, sight along the center line of the vehicle from the rear to the front. Rock the vehicle side to side 3 times to allow the suspension to stabilize. Jounce the front suspension 3 times by pushing down on the front bumper. Once the suspension has stabilized, measure the distance from the center of each headlamp to the floor. And mark these positions on the alignment screen with horizontal strips of tape. These will be used for the up and down measurement. Measure the distance from the center line of the vehicle to the center of each headlamp. And mark these positions on the alignment screen with vertical strips of tape. These will be used for the left and right measurement. Now we're ready to read our measurements. If you find the headlamp beam projections difficult to read on the screen, you can block the beam of the headlamp that is not in use. Don't cover the headlamp too close to the lens, because heat from the bulb could cause it to warp. When performing a screen alignment on an LH vehicle, the headlamps must be on high beam, while on all other Chrysler vehicles, the low beams are used. TSB number 083395, Revision A, addresses the headlamp beam patterns of 1993 to 1995 Visions and Concords. You may want to take a look at this TSB before continuing. When properly aligned, the headlamp will project a hot spot, which is vertically centered directly on the horizontal center line. A range of 2 inches above to 2 inches below is acceptable. Horizontally, the left and right headlamp hotspots should be 4 inches to the right of the vertical center lines. If an adjustment is necessary, rotate the vertical adjustment screw or the horizontal adjustment screw as necessary to achieve the specified high beam hotspot locations for LH vehicles. Then check the low beams. While this procedure is correct for LH headlamp alignment, keep in mind that other Chrysler vehicles use only the low beams for alignment and may use different specifications. Before performing a screen alignment, refer to Group 8L in the appropriate service manual for the applicable specifications. After the headlamp aim has been adjusted using the alignment screen, the bubble level and horizontal indicator on all vehicles except the Cirrus, Stratus, Breeze, and Sebring convertible can be calibrated if necessary. The bubble level is calibrated using the calibration screw. While the vehicle remains on the level surface, rotate the bubble level calibration screw in or out as necessary to center the bubble in the vial. There are a few different methods of calibrating the horizontal level gauges. Let's start with the LH vehicles. Again, after performing the screen alignment, if necessary, reposition the arrow sticker to the 0 mark on the horizontal gauge indicator. If the adjusting gear on the Sebring, Avenger, Stealth, and Talon is not centered on the 0 mark, pull up the stopper and disengage the large gear from the small gear. Then align the 0 mark with the center line and push down the stopper to engage both gears. Calibration for both the bubble level and horizontal gauge on the minivan is a little different. To calibrate the horizontal gauge, loosen the 3 screws and reposition the horizontal magnifying window so the 0 mark is clearly visible. As on other vehicles, you can calibrate the bubble level using the bubble level calibration screw. Vehicles not equipped with a bubble level or horizontal adjustment gauge include the Neon, Colt, Summit, Dakota, Wrangler, Cherokee, Grand Cherokee, Ram van and wagon, and the Ram pickup. On these vehicles, headlamp aiming is performed either by using the alignment screen, as we've seen, or special tool number C4466A. All fog lamps are adjusted using the alignment screen. On Neons and minivans, it may be necessary to disable the headlamps in order to provide a more accurate fog lamp projection. As on headlamps, when aligning fog lamps, measure the distance from the center of the fog lamp to the floor and mark it on the screen. With a properly aligned fog lamp, the top of the high-intensity area should be 4 inches below the horizontal fog lamp center line. Well, that just about covers headlamp aiming. Before we look at headlamp operation, try to answer this review question. The bubble level should only be calibrated, A, before attempting the screen alignment, B, after a screen alignment has been performed, or C, before aiming headlamps with the bubble level. The correct answer is B. After the headlamp aim has been adjusted using the alignment screen procedure, the bubble level on all vehicles, except the Cirrus, Stratus, Breeze, and Sebring convertible, can be calibrated if necessary. Like headlamp features, headlamp operation varies from vehicle to vehicle. Many vehicles remain independent of the body control module, or BCM, for their headlamp operation, while others are dependent on it for some or all headlamp functions. On vehicles not utilizing the BCM for most headlamp functions, the headlamp switch receives battery voltage through the power distribution center, or in some cases, the junction block. The headlamp switch then feeds the headlamp dimmer switch. The headlamp dimmer switch, located in the multifunction switch, feeds the low and high beams of the headlamps. And the switch also operates the optical horn, or flash-to-pass feature, if available. Chrysler vehicles that utilize the BCM for only some of their headlamp functions include Cirrus, Stratus, and Breeze, Sebring convertible, LH vehicles, and Grand Cherokee. These functions include automatic headlamps available on the New Yorker, LHS, and Grand Cherokee, and headlamp time delay, which is available on LH vehicles, Cirrus, Stratus, and Breeze, Sebring convertible, minivans, Cherokee, and Grand Cherokee. Let's take a look at automatic headlamp operation on the New Yorker and LHS. When in the automatic mode, the headlamps will turn on and off automatically, depending on the level of ambient light available. The auto headlamp light sensor, located on top of the instrument panel cover, sends a light intensity signal to the BCM. Based on this input, the BCM turns the headlamps on or off through the headlamp delay relay. The automatic headlamp system on the Grand Cherokee uses an automatic headlamp relay. If light intensity is low enough, the BCM energizes the auto headlamp relay, which then sends power to the headlamps through the headlamp dimmer switch. The headlamp time delay system is activated by turning the headlamps on while the vehicle is running, shutting off the vehicle, and then shutting off the headlamps within 45 seconds. The headlamps will stay on for about 90 seconds and then shut off. On LH vehicles, Cirrus, Stratus, and Breeze, the headlamp time delay system operates through a BCM-controlled headlamp delay relay located in the junction block. The Grand Cherokee uses the auto headlamp relay located in the junction block for its headlamp time delay operation. The BCM receives input from the ignition switch and the headlamp switch and controls the ground for the coil side of the relay. In addition, the BCM controls the amount of time the headlamps stay on. On 1996 minivans, most headlamp functions are controlled by the BCM. The headlamp switch provides a ground signal to the BCM, which then provides a ground for the low beam relay. The low beam relay sends power to the left and right headlamps through the fuses in the power distribution center. If the operator selects high beams, the headlamp dimmer switch provides a direct path to ground for the high beam relay. With this system, headlamp features like time delay are controlled through the BCM's operation of the low beam relay, rather than a separate headlamp delay relay. The headlamp delay system on the Cherokee operates through a headlamp delay module. After the ignition switch and then headlamp switch are shut off, the headlamp delay module will continue to power the headlamps for about 45 seconds. Like the Cherokee, the headlamp automatic shutoff system on the Stealth operates a little differently than systems on vehicles utilizing the BCM. A light automatic shutoff unit located behind the driver's side quarter trim panel operates the system. Here's how it works. When the headlamp switch is turned on, it sends a ground signal to the light automatic shutoff unit, which activates the headlamp relay, causing the headlamps to turn on. The light automatic shutoff system is activated by turning off the ignition and opening the driver's door. The light automatic shutoff unit then deactivates the headlamp relay, causing the headlamps to shut off. To turn the headlamps on again after they have automatically shut off, turning the headlamp switch to off and then on again, or the ignition switch to the accessory, or on position, will send a signal to the light automatic shutoff unit, which will activate the headlamp relay. If the vehicle you're working on is equipped with daytime running lamps, refer to the appropriate service manual for system operation. In the next section, we'll take a look at a sample problem with the headlamp system. But first, try to answer this question. Which of the following vehicles uses a separate headlamp delay relay for turning off the headlamps? A. Grand Cherokee, B. LH vehicles, or C. Minivans? The correct answer is B. On LH vehicles, Cirrus, Stratus, and Breeze, the headlamp time delay system operates through a BCM-controlled headlamp delay relay located in the junction block. Now let's look at a sample problem with a headlamp system. A minivan is brought into the dealership with low-beam headlamps that don't turn off. As always, we first verify that the condition exists. Verification isn't difficult here. It's obvious that the condition exists. The Minivan Body Diagnostics Procedures Manual refers us to Test 3A, headlamps that will not turn off. Step 1 instructs us to connect the DRB3 and read the headlamp switch sense. This is a signal that headlamp switch provides the BCM. When it receives this signal, the BCM grounds the low beam headlamp relay to provide power to the headlamp. The DRB3 shows headlamp switch open, so the switch and its circuit is not the problem. Also, we know the BCM is not keeping the lights on by mistake. Next, we'll disconnect the headlamp low beam relay in the power distribution center and check to see if the headlamps turn off. Since the headlamps turned off, we know the problem is somewhere in the relay or its circuit. To narrow down the cause, we first disconnect the multifunction switch connector located under the steering column shroud. With the DRB in the ohm meter mode, we probe the low beam relay control circuit to check for continuity to ground between the headlamp dimmer switch and the relay. Resistance is above 5 ohms, so we can rule out a short to ground on this side of the circuit. Next, we'll disconnect the probe, and again with the DRB in the ohm meter mode, probe the headlamp relay control circuit, this time to check for continuity to ground between the multifunction switch and the BCM. Resistance is still above 5 ohms, which tells us this part of the circuit is not shorted to ground. As a result, the low beam headlamp relay is the probable cause of the problem. After replacing the low beam headlamp relay, we test the system to ensure it's functioning properly. This time, the headlamps did turn off, so we know the problem has been resolved. Well, that's all the time we have for today. I'm sure this month's program will prove helpful in the future. And join us next month when we look at the DRB3 update and the use of the peripheral expansion port module. We'll see you then.